Hello, Algebra 2. Even though that snow's falling, the math is still calling, which means today we're going to do some notes online. Today's objective, 8.4, says students will be able to solve exponential equations. And that, my friends, is what we're going to do today. So now that we're confident working with exponents and logarithms and rewriting them so that we can make exponents become logs and logs become exponents, we can really move forward with solving those types of equations. So today we're going to look at exponential equations. Now, if we want to solve an exponential equation, we're going to convert it to a logarithm. Spelling is hard sometimes. So we're going to put it in logarithmic form. Now, before we do that, it's important that our equation is into the form b to the x equals a, because that's our form that we know how to make that logarithm. So what we're going to do when we're solved, we're going to find the exact solution, which will keep it in logarithmic form, and we're also going to round it to the nearest hundredth. So let's look at letter A here. 5 to the x minus 3 equals 10. So notice we're in the form that we want. All we have is our base, our exponent, and our argument. So to rewrite this as a logarithm, it would be log base 5 of 10 equals x minus 3, right? That variable is what it's equal to now. So all I need to do to get x by itself is add 3 to both sides, right? So that tells me that x is going to equal log base 5 of 10 plus 3. And from there, that is our exact solution. That's the logarithm. But we're going to get our calculator involved here, and we're going to type that in. So I'm going to pull up, let's see, log base 5 of 10, and then plus 3. I get 4.43 when we round to our nearest hundredth. 4.43. Now, I did Math Alpha Math for that one. Remember, if you need to do change of base, it's the log of the argument divided by the log of the base, and then you'd say plus 3. You'll get the same value, okay? So for those of you with those newer calculators, Math Alpha Math, if you're still rocking a TI-83, no problem going retro, but you'll need to do change of base. All right, let's do one more together, then I'll have you try one on your own. Let's look at letter B. So e to the 10x minus 8 equals 13. So this one, our equation isn't in the form that we need. We have this minus 8 that we need to get rid of. So I'm going to add 8 to both sides. 13 plus 8 gives me 21. So e to the 10x equals 21. So now that I have the base isolated, I am set to the b to the x equals a. I can convert this to a logarithm. Remember, if our base is e, it's the natural log. So we'll have the natural log of 21 equals 10x. And all I need to do to get x by itself is divide by 10. So x will equal the natural log of 21 divided by 10. That would be the exact value. Now in my calculator, the natural log of 21 divided by 10, 0.30. That would be our approximate value, our rounded value. All right, so each of these problems is going to have our exact value and a rounded value. All right, so I'm going to pause here. I want you to try C on your own. What would we do to get C? And then we'll go through it together. All right, so hopefully we noticed we can't change the base, right? We got to get rid of this 2 times 3 to the x plus 5. So I'm going to start by dividing both sides by 2. So I will have 3 to the x plus 5 equals 16 divided by 2 is 8. And now from here we can convert it to a logarithm. So it would be log base 3 of 8 equals x plus 5. To get x all by itself, just subtract 5 from both sides. So I have x equals log base 3 of 8 minus 5. That would be my exact solution. Now, remember, for our rounded value, we need log base 3 of 8 and then minus 5. in our graphing calculator, negative 3.11. Hopefully we did pretty well on that one. Remember, we can't change the base. So anytime we see something being multiplied by the base, we got to divide it out. All right, same if we see something being divided, we'd have to multiply it out. So let's look here. Why don't you go ahead and try letter D on your own as well? Give it a shot now that we have this new information. What would we do to find our answer for D? All right, hopefully we had enough time there to get D done. Let's go ahead, start by subtracting 3. All right, subtract 3 from both sides. So I'd have 12 to the A equals 29. That A looks a lot like a 9. I'm going to try to fix that. There we go. 12 to the A equals 29. So converting to a logarithm, that'd be log base 12 of 29 equals A. So in my calculator, I do log base 12 of 29, 1.36 when I round. A equals 1.36, and there we have it. All right. Why don't you go ahead and try letter E on your own? So go ahead and pause the video, give it a shot. Let's see how we do. Hopefully that was enough time. If not, go ahead and pause it again before we go through it. First step here, we would need to isolate that base, right? So we're going to subtract 2 from both sides. So we'll have 10 to the x minus 10 equals 57. Now remember, if our base is 10, we don't have to write that in our logarithm. So it would just be the log of 57 equals x minus 10. To get x, just add 10 to both sides. So we'll find that x equals log of 57 plus 10. So in my calculator, log of 57 plus 10, press enter, we get 11.76. X equals 11.76. When we round to our nearest hundredth, there would be our two solutions. Now let's go ahead and do letter F together here. Looking at letter F, we have multiple steps that we need to do here. So it's just like solving for a variable. The first thing I'd want to do, think of e to the negative r as our variable. I'd want to add 6 to both sides, right? So I'm going to add 6 to both sides. So I have negative 10 e to the negative r equals negative 25. Okay. Now I got to get that e all by itself, so I'm going to divide by negative 10, both sides by negative 10. And when I do that, I get e to the negative r equals, I'm going to simplify this fraction, it would simplify to 5/2. So now that we have our base exponent equals argument of our logarithm, so the natural log of 5/2 equals negative r, or if I divide both sides by negative 1, r equals the negative natural log of 5/2. So let's put that in our calculator. The negative natural log of 5/2 equals negative 0.92 equals 0.92. And there we have it. So you see how the process stays the same. We just got to isolate that base. Right? And to do that, we undo the operations that are going on around it, okay? Go ahead and turn the page here. Why don't you go ahead and try letter G on your own? Go ahead and give letter G a shot. We want to find both the exact solution and the rounded solution. All right, so hopefully we noticed that negative 2 e to the 3x, we got to divide out that negative 2, right? E is our base here, so that's what we got to get all by itself. So we'll divide that out. We'll get e to the 3x equals negative 18 divided by 2 would give me 9. So when I convert this, the natural log of 9 equals 3x. Divide both sides by 3. I would get x equals the natural log of 9 divided by 3. Or, in my calculator for a rounded value, the natural log of 9 divided by 3 is 0.73. Excellent. Okay, let's go ahead and try letter H together. There's a lot of steps going on here. Let's go ahead and give it a shot, see how we do. So the first thing I'm going to do is I'm going to add 6 here. Add 6 to both sides. So I have negative 2 times 5 to the 10x plus 8 equals negative 34. Now, remember, we can't change our base. Our base is 5, so we can't do this negative 2 times 5. We have to undo it. So I'm going to divide both sides by negative 2. When I do that, I get 5 to the 10x plus 8 equals 17. So now is where we do that logarithm. So it would be log base 5 of 17 equals 10x plus 8. So now look at these things I have to undo for x. First thing is subtract 8 from both sides. So log base 5 of 17 minus 8 will equal 10x. And then to get x all by itself, just divide by 10. Divide both sides by 10, of course. So I have x equals log base 5 of 17 minus 8, all divided by 10. There's our exact value. Now putting this in the calculator can be a little tricky here. So what I'm going to do, I'm going to throw parentheses around my numerator. So I will have log base 5 of 17, then minus 8, and then close that parentheses to make sure it gets the numerator all done first, and then divide that value by 10. When I do that, I get negative 0.62. So x equals negative 0.62. And there would be my exact value and my rounded value. All right, that was a lot. Let's try another one together. Let's try letter J together. So looking at letter J, I need to undo this addition for plus 2, so I'll subtract it. So I'll have 2 times 20 to the 6x minus 7 equals 14. And then divide both sides by 2. So 20 to the 6x minus 7 equals 7. Now as a logarithm, that would be log base 20 of 7 equals 6x minus 7. So I'll add 7 to both sides. So log base 20 of 7, and then plus 7 will equal 6x, and then I'll have to divide both sides by 6. So that'll tell me x equals log base 20 of 7 plus 7 divided by 6. So again, careful putting this in our calculator. We're going to put parentheses around the entire numerator. So math, alpha, math, log base 20 of 7, and then plus 7. Close that parentheses to say we need to do the numerator first, and then divide that by 6, and we get 1.27. That equals 1.27. That would be our rounded value. So again, 2 answers for these. The same value, one's presented as the exact value, one's presented as the rounded value. Okay, this has been a lot. Depending on your comfort level, I either want you to try all 3, K, L, and M. If you're feeling confident, I want you to do all 3. Or if you want to take these one at a time, that's fine too. But either way, I want you to get started at letter K. If you're feeling confident, do letter L. If you're feeling confident, do letter M. If you're still not sure, just do letter K. Then we'll have us go through it. Then do letter L. We'll go through it. Then do letter M. We'll go through it, okay? So I'm going to ask that you pause the video, do what you think you should be doing right now, and then once you feel ready to check your work, go ahead and resume the video. All right, hopefully that gave you enough time to get some work done. Let's look at letter K here. So we're going to start by adding 2 to both sides. So we'll have negative 2 times 20 to the x plus 7 equals negative 8. Divide both sides by negative 2. So we'll have 20 to the x plus 7 equals 4. So now I'm going to make my logarithm. Log base 20 of 4 equals x plus 7. And then to get x, I'm just going to subtract it over. So x will equal log base 20 of 4 minus 7. All right, now in my calculator, log base 20 of 4, and then minus 7. This is going to be a nice negative 6.54. 6.54. Excellent. All right. If you already did L and M, go ahead and continue the video. If you haven't, pause it, start L, because we're going to check it in 3, 2, 1. Here we go. So I'm going to start by subtracting 4 from both sides here. And remember, I can't change my base, so I never want to do like 10 times 12 here. That is not the move. Instead, I want to divide by 10. I want to get rid of it. So I'll have 12 to the 1 minus 9x equals 4. And then my logarithm, log base 12 of 4, equals 1 minus 9x. And now I got to solve for x here. So I'm going to start by subtracting 1. So log base 12 of 4 and then minus 1. And that'll equal negative 9x. But then I got to get rid of that negative 9. So I'm going to divide both sides. So x will equal log base 12 of 4 minus 1 all over negative 9. I'm going to have to give me a little bit more space here. So again, when we have all these operations in our numerator, let's put that in parentheses. So we'll do log base 12 of 4 and then minus 1 and then divide that. Notice how I close that parentheses so that I can divide it all by negative 9, 0.05 when we round. 0.05. Excellent. All right, and now all that's left is letter M. If you haven't tried letter M yet, go ahead and give it a shot. Otherwise, we're going to do it together in 4, 3, 2, 1. Hopefully we realize first step, got to get rid of this minus 7, so we'll add 7 to both sides. 4e to the 7 minus 4x would equal 30. And now we'll divide by 4 to get e all by itself, right? I know it might look like 4e is the base, but that's not the case here, right? 30 divided by 4 would simplify to 15 halves. So that means the natural log of 15 halves equals 7 minus 4x. So now to get x all by itself, subtract 7. So the natural log of 15 halves minus 7 equals negative 4x. And then divide by negative 4, so that means x will equal the natural log of 15 over 2 minus 7, all divided by negative 4. And now we got to put that in our calculator. Again, a lot's going on in our numerator. Let's put it in parentheses. The natural log of 15 halves, then minus 7, close that parentheses, divided by negative 4, and we get 1.2. That's equals 1.25. All right, and there we have it. Hopefully we're feeling at least somewhat confident. Obviously with this being virtual, not ideal. If you have any questions, please feel free to reach out. We'll also have advisory tomorrow. If we're in person, that would be a great time to come see me. Let me know if you have any questions. Otherwise, practice problems for this are available on the class website. I would highly encourage you to look at those. Other than that, though, I hope you all are staying safe, staying warm, and I hope you all have had a great time learning some math. I wish you all a great day. I'll see you next time.